All right, so we are taking a look here at day one, which is linear inequalities and modeling with inequalities. So your notes for the unit here, which we're going to get into tomorrow, are on the second page. So keep that in mind as you're working through the unit. But we're going to start with graphing linear inequalities. Now, the first graph here is a graph using y is greater than or equal to 1. We kind of want to pretend like it's just an equation to start with. So y equals 1. So remember, y equals 1 is a horizontal line, and it crosses through the y-axis at 1. So it's got a slope of 0. That's why it's like 0x plus 1. Okay, and there's my line. The other equation we have, okay, is going to be another line. This is x equals 5. This is going to be a vertical line, and it crosses through 5 on the x-axis. So it's where all the x coordinates are 5. So you got this point up here, which is the point 5, 6, 5, 5, 5, 4, 5, 3, 5, 2, 5, 1. All these points have x coordinates of 5, and we get this line. So what you're going to do when you're doing your graph is you're going to shade your line. So remember that the first one is a greater than or equal to symbol, okay? So we see greater than or equal to. This tells me two things. It tells me it's a solid line, and it tells me that I'm shading up, okay? So, or in this case, the y values that are, or x values, or y values in this case, that are greater than that line. So since this is the blue line, I'm just going to draw lines going up from here, okay? If you see just a greater than or less than sign, then we're going to do a dotted line instead of a solid line, indicating the points on the line do not work in the inequality. So if I see a less than or equal to, then that is also telling me it's a solid line, okay? And that I'm going to shade down on my line. Now, it's the x values that are less than that line, so it's actually going this way, all right? And then the last thing I normally would do is put an S in that solution set. We're going to hold off a minute because there is another part of this that we're going to do. We also should have our equations listed. So this is x equals, or we could say is less than or equal to 5. Let's get that less than or equal to symbol in there. Less than or equal to 5. And our other line, since there's two lines in the graph, is y is greater than or equal to 1. So is the point 1, 2 a solution? Well, all we need to do is basically just go check to see whether or not that point is inside our solution set, inside where the double shading is. So the point 1, 2, right, is right here. There's 1, 2. So is that in the solution set? Yes. And the point 1, 1, which is right below it, is this in the solution set? Right, that also answer, well, that's not in the right spot, but so you guys get the idea that this point is in the solution set as well, because it's on the line, and on the line counts. So both of the answers here are going to be yes, okay, since the point is in the solution set for both inequalities. And then is 1, 1 a solution? Yes, okay, since the line is solid, any point on the line is part of both solution sets. All right, so same thing. Okay, normally though for inequalities, we also want to label an S inside here. So we would put an S there, which just stands for solution set. All right, so number 2, we're going to go graph our lines. Remember, what we need to do first is actually get the y equals mx plus b form, which we have. So for the first line, which is in red here, we know that m is 2, and that b is 1. So we're going to start by putting a dot at 1 on the y-axis, okay? And then we're going to go up 2 and over 1, and we can put dots down for ourselves, or down 2 and left 1, and then we are going to make our line. Now remember, this line, okay, is a dotted line going through these points. So keep that in mind as we're working through here. So dotted line going through the points up, and since it's less than, we're going to shade below the line. We're going to shade down here. Now, I don't like to color all of this stuff in, okay? I'm just putting some lines headed down in this direction below the line. And then when I do the second line, which is y equals negative 3x plus 2, the y-intercept is negative 2. So put a dot at negative 2 on the y-axis. And then negative 3 over 1. So m equals negative 3 over 1. So that means we're going to go down 3 and over 1 to the right, or up 3 and 1 to the left, okay? And hopefully you guys get the idea here. And then we're going to draw our line. And since this is an equal to graph, we're going to draw ourselves a solid line here, okay? Solid line to the point. I'm just going to use my straight line tool here. But remember, what you essentially just need is anything that lets you draw a straight line. So just keep that in mind. And then this is a greater than or equal to. So we're going to go ahead and draw. Now you noticed how all these lines were going down before. Now I'm drawing mine pointing to the right. So it's easy to see where the shadings overlap. Okay. And then on the same graph, we're also going to do the graph. So let's answer the first questions here. Is the point negative 2, 4 in the solution set? If we look at negative 2, 4, okay, negative 2, 4 is up here, right? And is that point in the solution set? No. And the reason it's not is it's in the solution set for the y is greater than or equal to negative 3x minus 2, but it's not in the solution set for the top equation. So no, we could just say since the point, or just say the point is not in the solution set for both inequalities. And that's enough, okay? All right, and then I'm just gonna move this down so it's a little easier to see. And then is 1, 3 in the solution set? So once again, if we head over to 1, 3, that's right here. All right, keep in mind that is on the dotted line. Oh, we broke something. That's on the dotted line. So that is another no, okay? All right, no. Points on the dotted line are not included in the solution set. So once again, so the point is not in the solution set for both inequalities. Okay? Now we're going to graph this equation, 2x plus 4y equals 8. And it should say less than or equal to 8. So remember, we want to get this in our y equals mx plus b form. Okay? So we're going to want to subtract the 2x from both sides. And then we want to get rid of that 4 in front, so we're going to divide everything by 4. So I'm going to get 4y. And because the x appears first in the formula, we're going to put that negative 2x in front. Now remember, if this were a negative 4 in front, the next step is to divide by 4. If this 4 were negative, we want to make sure that we end up flipping the inequality around. So remember, when you divide by a negative, you got to make sure you change that inequality. So we get y is less than or equal to negative 1/2 x and then plus 2. So we're going to go graph 2, which is right here. We get negative 1/2, so we're going to go down 1 over 2. All right, up 1 over 2. And then that's our line. So we can draw the rest of the line if you like. All right. So we're going to look like this. And it is a solid line because it's less than or equal to. And because it's less than or equal to, we are going to go shade down here. Okay. So we're just going to go ahead and shade down. And when we do that, we get this triangle here, which we're not going to do the perimeter and area on this one. But this would be the triangle that we're looking for. Actually, it's not. So the region that's actually covered by all three inequalities is this region right here. Okay. Now we can't really find the area and perimeter of this because number one, it's not a triangle or a rectangle and it goes on forever. Okay. So we got to be careful there. All right. But that's the region, that's the shaded region. So we'll do letter D on the next one. Okay. So let's head one more question. Let's head down to the next page. Okay. So on the triangular region in the plane. Okay, so for number 3, we're going to start by plotting our point. So we have the point right here, 0, 0, 1, 3, and then 2, 1. Let's try this again. And 2, 1. All right, it's pausing. The other point is at 1, 3, and then the last one here is at 2, 1. So if we were to draw, we want to come up with a set of inequalities that describe this region. So what we want to do is basically draw and extend straight lines that go through those points. So let's go ahead and grab some line here. And you can just use a straight edge, and you can also count, like it's going up 3 and over 1. So if we just continue that pattern, we know the slope. That line is way too thin. All right. So, and there's our inequality. And then in order to cover, so we know that this shape is essentially going to make a triangle. Okay, so the triangle, you can kind of look at it, is going to go and connect these points. All right, together. So where would we need to shade from that line in order to cover that triangle, right? We'd have to shade down from the line. So this is the triangle we have, okay? So what we're going to essentially need to do is if we wanted to shade this line, we would need to shade the region down here, okay? This is where we need to shade to cover that line. So in order to figure out the equation of the line, we need to get the slope and then the y-intercept. So you can see like the slope is going up 3. Oh man, we broke it. We're going up 3 and over 1 to the right. So our slope, right? Slope is 3 over 1. And the y-intercept is crossing at 0. And we're shading down. So our first inequality is going to be y is less than or equal to, because we're shading down, and then 3x plus 0. Or just 3x. Okay? The second line, same thing here. Change color here. Okay? So is going to go from, and you can follow the point here. Here's this line right here. So we're going down 2 and then right 1. So there's our line. Okay, just not on the spot where we want. All right. So we can see by extending the line where the graph crosses the y-axis, which is up here. That's at 1, 2, 3, 4, 5. And the slope is up 2 and left 1, or down 2, right 1. So the slope is going to be a slope of -2, right? Okay, well, that's not what we wanted. So the slope for this line is -2, and the y-intercept we said was 5. And if we want to shade the line to cover that region, we're going to have to shade down again. Okay, we have to shade down. So we should use a different color. We should use blue again to cover that triangle. So now our second inequality is y is less than or equal to, and then it's negative 2x plus 5. And our last inequality, we can do green here, okay, is going up 1 and over 2. So we can follow that pattern and extend our line out. So it's going to have a slope of 1/2 because it's up 1 and over 2. Okay. That's supposed to be an m. And it goes right through the origin. So b is once again 0. So our last line, and to cover our graph, we're going to have to shade up to cover that triangle. So this is going to be y is greater than or equal to 1/2 x plus 0, or just 1/2 x. Those are the three inequalities. So that's how we're going to essentially build the inequalities. And right now, we're basically going to talk about how to find the perimeter and area of this little region, this triangular region here. So the easiest way to do the area is just to encase this in a rectangle. So if you go all the way around and through each of the vertices, you draw yourself a straight line going across so that you can create a rectangle around the shape, then what we're essentially going to do is find the area of the rectangle and take away the area of these three triangles. And the great part about doing this format where you draw your rectangle around it is that the triangles that you're left with will always be right triangles. So the area is just 1/2 the length of each of these two legs on the side. So it's kind of easy and a nice way to do this. So we can just kind of label the regions for ourselves. So we could call like this is region 1 here, here's 2, 3, and then we can go find the area. So the area of triangle 1, okay, remember is 1/2 base times height. So 1/2 sorry, trying to. And then the base for the triangle 1 here, right, is that long. It's 2 by 1. So it's 1/2 2 times 1, which is just 1. Okay, we have the other area of the triangle for triangle 2. Okay, so triangle 2, the area of triangle 2. All right, no, this isn't working, but get the idea. So triangle 2 here has a height goes all the way to 3 and a length of 1. So we're going to do 0.5 times 3 times 1, which is half of 3. So that's going to be 1.5. And then the other region is triangle 3 here. Just make it bigger so easy to see. So the area of triangle 3 and triangle 3 once again also has a length of 3 and a width of 1. So we can do that same thing here. And so that's also going to be 1.5. And then all we're going to do essentially is just subtract that from the area of our rectangle. Okay, so the area of the rectangle, and that has a width of 2 here and a length of 3, or a width of 3. So that's 2 times 3, which is 6. And then we're just going to subtract. So we add 1, 1.5, and 1.5, that's 4. And then we can subtract away from 6. So the area, the total area is equal to 6 minus 4, I should say. which is 2. Okay, perimeter is a little bit tougher. That's going to be our essentially just doing and solving for the length of the line. Now, keep in mind that we've already drawn these rectangles, which have lengths of 3 and 1. This has a length of 1 and 3, and then this is 1 and 2. Okay, well, I should say 1 and 2. Let's walk back here real quick because there's an error in the last question. Triangle 2 has not a length of 3, but a length of 2 here and 1. So instead of being 1.5, this should be 1. So we got to fix this. This should be 6 minus 3.5. And so that is 2.5. So that is the area. All right, and then the last thing we're going to do is eventually find the perimeter. So remember, perimeter equals add all sides, and you can actually use Pythagorean theorem to do this. So we know it's a squared plus b squared equals c squared. And remember, the c squared is the actual length of the segment. So that's what we're trying to find. So we have a length of 3, so 3 squared. It's not working. So 3 squared plus 1 squared is going to be the length of that line. The squared's not working here, but hopefully you guys get the idea. Squared, and that's equal to c squared. And so this is just 10, so the square root of 10 is going to equal the square root of c squared, which is c. So that's the length of the first line. The second line, which is nice, is horizontal. We could just count. That's at a length of 2. And then the third line, sorry, that's not true. This is that side right here, which is 2 and 1. So once again, we're going to use Pythagorean theorem to get that length. So a length of 2 and a length of 1. And then we can just do Pythagorean theorem again. So we can do 2 squared plus 1 squared is equal to c squared. 2 plus 1 is 5. That's equal to c squared. And then square root of that is going to be the length of c. So that's the square root of 5. And then the last one, once again, has a length of 1 and 2 as well. We already have that calculated, so we don't have to do it again. So the perimeter is just going to equal those three put together. So square root of 10 plus 2 square root of 5. There's 2 of them, so 2 times the square root of 5. And then you can just take your calculator, type it in, and round that to the nearest 10th. So square root of 10 plus 2 square root of 5 is 7.6. And so you could use the distance formula, or you can just use Pythagorean theorem. Okay, so we're going to just do this first part. We're not going to worry about the perimeter area. Also, for this question, when you are finding the area, keep in mind that this area is actually a lot easier because we know the base, we can actually count it, and we can count the height. So in instances where you don't have to worry about doing a rectangle around it. You know, it's just 1/2 8 times 2, 4, 6. So 24 is going to end up being the area. But if we're doing the inequalities, remember we're going to essentially graph this line right here, and we're going to shade to the right. Okay, we're going to graph this line over here. So if we extend these lines out, okay, and you can see this is going up 3, and essentially up 2 over 3. So if we keep that pattern going, about there. Oops. For ourselves. We'll have our line. And then remember for this line, we would want to essentially shade down from here. So keep that in mind on this one, that this line is going to be shading down. All right. And then our last one is going to be, we'll do that one in green here. It's going to be this line right here. And you can see like this has a slope. It looks like it's going, well, up 3 and all the way over there. So if we continue this line out, and we'd be shading up from this line to cover the section. So if you just find a couple points on the line that you can graph, okay? So we have this point right here, and we know that the other point that's definitely on the line is the line where it crosses the x-axis. And so if you count the rise over run here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, that's going to make a slope of 4/6, which is 2/3. Let's do that for the green line here. Okay, so slope. And then the y-intercept, where it's crossing the y-axis, is at -4. And remember, for this line, we're shading up, so it's going to be y is greater than or equal to 2/3 x minus 4. Okay, the blue line, we can do the same thing and count the slope. This one's down 4 and right 6. So the slope of the blue line is going to be -2/3. And the y-intercept is at +4. And we're shading down, so this is y is less than or equal to -2/3 x plus 4. And then the other line is the red line, which is a vertical line. So that's going to have an x equals, and it crosses through 0. And because we're shading to the right, instead of it actually being equal, we're going to be greater than. That would be our 3 inequalities. Okay, so extra credit if you want to try number 5. And you don't have to worry about doing letter C if this is on here. Okay, so don't worry about doing that. Just A and B for extra credit. We'll see you guys tomorrow.